Assalamualaikum warahmatullahi wabarakatuh. My name is SEMM1213 and I will be the presenter for section 3 group 3 for Dominoes challenge. So first of all, I will introduce our group members. The first one is Abdul Hamid Farid Mohammed, and second Amir Haikal, Colchester Conrad, Muhammad Arif Hakim bin Muhammad Asnizam, Muhammad Hafizah bin Savitri bin Muhammad Sa'ad, Muhammad Nasrullah bin Muhammad Shukri, Nur Irdina binti Edi Amin, and Sylvia Rizaldi. So first of all, in this presentation we will show a process of Dominoes challenge. So the first one is planning phase, and then the second one implementation phase, and the third one reflection phase. So for the planning phase, so we held a meeting, and then we try to understand the task, and we list out our problem statement. And the first one is 200 domino set was given to each group, and then the second one, the area to be Dominoes challenge is 1 meter times 1 meter times 1 meter, which is 1 meter cubic. And the third one is modification on Dominoes is not allowed. And the fourth one is Dominoes challenge must conduct with station that will be trigger or prevent the Dominoes from falling too fast. And the fifth one is the Dominoes challenge must be finished within limited time 60 seconds. So our objective in this Dominoes challenge is to apply and gain benefits of dynamic principles during class, and second, to enhance the creativity and innovation of the student, which is challenging us to how to slow down the dominoes from falling. And the third one also same, to nurture problem solving and troubleshooting skills. And the fourth one is to ensure students work productively in team and demonstrate basic leadership. So this is our planning phase, which is on 11th December. We're planning the stage of Dominoes challenge and dividing tasks such as sketching and buying item, and building a stage, and then recording. And then we're discussing the suitable stage of Dominoes challenge, which is after the sketching. We discuss again we discuss again to get a perfect plan for our Dominoes challenge. And on 21st December, we're making parts for every stages of the Dominoes challenge tower, which is we all agrees on the structure. And 22nd December, we compile all part to become one unit Dominoes challenge tower. And 26th December, we're recording the Dominoes challenge, and it succeeds. So I will explain how the movement of the dominoes and our structure. So first of all is a sliding tower. The sliding tower will be start line of the Dominoes challenge with two marbles that will be rolling down following the given track of the slidings. As the marble rolling down into the most lower sliding, it will keep increasing the velocity, and when the marble left the most last sliding, it will push the dominoes on the stage 1 and make it fall. So as you can see on the diagram, this is our dimension for the sliding tower, which is 100 cm height, and the base is 60 centimeter. So and this is the sliding on the diagram, sliding 1, which is the dimension is 60 centimeter, and the barrier to make the marble not falling down is 1 centimeters, and we're using a manila cardboard for doing this. And then we also use a flat sliding, which is the dimension is 42 centimeters width, and then 14 centimeters slope, and then 6 centimeter. So as you can see, for our angle of the slope for the sliding one is 5.71 degrees for every slope, for every slide. And then the acceleration that we get from the marble is 0.162 centimeter per second squared, and then the work done is 0.5886 newtons, and our velocity of the marble is 17.64 centimeters per second. And then the next one is our stage is stage 1 after the sliding tower. The dominoes on side down of left in the picture will be fall, and it will continue until it pushing the small ball at side upper of left in the picture. The ball will move along the route rolling down because of the slope and pushing the dominoes inside the mechanic stage 1. The dominoes inside the mechanic stage 1 will fall along the route, climbing the stairs and make one domino fall. That will pull a string to become a load of the pulleys. Dominoes that fall will moving down and make the string on the other side of the pulley, moving upward and push an elastic floor to move set dominoes on stage 2. So as you can see, this is dimension of our sliding, which is 6 centimeter height and 60 centimeter base, and then 10 centimeter width. So as you can see, the slope of our sliding one from our calculation is 6.84 degrees. So and then the second one, when we find the slope of the sliding is 50.3 centimeter, and our acceleration of the marble is 0.194 centimeter over second squared. And then this is our work done, which is same as before because the energy is reserved. So the work done is also same, 0.5886 newton, and then velocity of the marble is 4.41 centimeter over second. So for the next stage is stage 2. The dominoes that fall will moving down and make the string on the other side of the pulley moving upward and push an elastic floor to move set dominoes. In the highest place of the dominoes building, there is a single dominoes that tied up with a string that connected with the trapdoor on stage 4. So as you can see, this is our design for stage 2, which is a L shape. And you can see the dimension. We make the barrier is 5 centimeter to avoid from a marble and the dominoes from falling apart. So as you can see in the pictures on the right, on the top right, the dominoes on the square one is a stage dominoes, which is we arrange by staging a dominoes from low to high, and then the structure that we use to support our stage 2 is we using a pillars which is 8 centimeter length. And the next one is a stage 4. So the string that being pulled from stage 2 will open the door that stop a ball on stage 4 to roll down with slope theta A. The move to the second slope theta B. The ball will keep rolling down until reach the shaft, rolling with centrifugal movement along the side of the shaft and get into the hole in the middle of the shaft. The ball that get inside the hole and fall to the stage 3. So as you can see on the picture on the right, there is a sliding 1 and sliding 2, which is connected or which is arranged side by side but in a different direction. So the marble will going down from sliding 1 and then go to sliding 2 and then hit the dominoes, and then the dominoes will hit the ball, and then the next ball will go into the shaft, centrifugal movement. So as you can see, the angle of our sliding is 5.73, and then our acceleration is 0.613 for the marble, and then the slope, the angle of sliding 2 is 3.3 degrees, and the acceleration is 0.721 meter over second squared for the marble, for the second sliding, and then the work done is same. And the velocity for marble on stage 4 is 13.17 centimeter per second. And then we move to stage 3. With the ball from stage 4 to fall to stage 3 along through shaft, it will make the Dominoes on stage 3 fall along the route on picture and push the ball near the shaft, and the ball will move along with centrifugal movement along the side of the shaft and get into the hole in the middle of the shaft. As the ball get into the bucket on the stage 1, it will become the sign of the mechanic of Dominoes challenge already done. So as you can see on the top diagram, this is our dimension. So the marble will hit the Dominoes, and then the Dominoes falling, and then at the end of the Dominoes, they will place a marble. So the marble that we hit by the Dominoes will enter the shaft through centrifugal movement. So this is our dimension of the L shape, and then this is dimension for our shaft. And then for the implementation phase, we will show a video of our Dominoes. This is our Dominoes challenge. And then for the reflection phase, we will summary of our entire work. So what we do first is a planning, which is we sketching by using a Clip Studio Paint, and it's made by Silvisa Rizaldi, and then the Panyata Muhammad Rasulullah, and then we held a meeting. And then we making a platform which is all our member is included and cooperate in making a platform, and then we recording and arrange the Dominoes. So what we can finalize from this project is a momentum and impulse concept is very helpful for us to complete the Dominoes challenge. The basic physics is straightforward. Standing a domino on its end stores a certain amount of potential energy, which is released by pushing it over. However, the force required to topple the domino is smaller than the force it generates when it falls. So the collision inelastic for the Dominoes challenge, which is the main source of lost energy. And in practice, the Dominoes can slide along the floor when they are hit, and this can seriously impact the toppling. And then this is our self-reflection, that what we can conclude that a cooperation of our member is very important in succeeding this project. And then this is picture of us after done the structure, complete the structure, and then the right picture is a picture of us arranging the Dominoes together. And then the next one is our picture. This is the picture. For the middle picture is the picture of our structure before arranging the Dominoes. and the right one is the structure of our sliding towers. And then this is our group, and so what we can conclude that what our objective in this project is actually achieved, which is we applied the dynamics term in our project. And then the second one is leadership. The leadership also we succeed, and the limited time for 60 seconds of our Dominoes challenge is also succeed. I think that's all from us, from group 3. Thank you.